This is the SC Trebuchet project for Team Slingers. Our architecture concept is the stationary trebuchet. We chose that to reduce the complexity of the system, avoid added weight, improve ease of manufacturing and assembly, decrease variables during operation, and improve accuracy. We also choose to go with the hanging counterweight to complete a more vertical fall of the counterweight at launch.
Here are some examples of some of our subsystem design specifications. The big lesson learned here was that a lot of the subsystem design specs were related to the different interface agreements between the systems.
We mapped out our subsystems so that we could see our interfaces with a boundary diagram. And then as we progressed and used simulation, when we did our DSM to determine how efficient we were, we saw that there was a clustering around the sling arm and the sling, the arm, and the chassis, which was the focus of our simulation. So to show the DSM would have told us that in the first place, how to deal with the different interfaces.
From a system verification validation standpoint, much of the plans, both for the system we created and we approached it from evaluating the interfaces of each subsystem to make sure that they largely spatially and seamlessly interface with one another. From a performance standpoint, we were left to really just go through the motions of firing the system over and over again, focusing on evaluating different aspects of it. So making sure that the trigger mech released smoothly, making sure that as the sling pulled through, it wasn't contacting anything, and that it was releasing at the right point. And that led us to basically doing some iteration to make sure that we were getting optimal results from what we could with the product as it was defined at that point in time.
Finally, lessons learned. First off is using system testing to find ways to improve the performance of the trebuchet. Secondly, requirements must be documented and understood early in the project cycle by all team members to ensure the team members understand the deliverables. Thirdly, great design shows opportunity to meet customer deliverables, and tuning allows engineers to increase performance. So great design doesn't accomplish the whole objective, but it takes the fine-tuning and the system validation at the end. Supply chain and sourcing was very critical at the beginning of the project, as opposed to thinking of this at the end once the design is set, and finding limitations based on sourcing. Keeping in mind the supply chain capabilities early is important to making sure you get it right the first time. And then lastly, be disciplined when architecting the system to not jump prematurely into design choices, and then minimize your total solution opportunities, as has been touched on in previous sessions. Thanks.